learn what a semiconductor is. So what would you think a semiconductor would be? So a semiconductor wouldn't be a good conductor, and a semiconductor would not be a good insulator. It would be a resistor, and so in fact sometimes they actually use semiconductors as resistors, especially on printed circuit boards. So we have a thing called conductance, and of course everybody here probably knows what the best conductor of electricity is, best known conductor of electricity. They added 2 elements to the periodic table here last year. Did y'all read about that? I forgot what it is and what group it went into. So even as long as the periodic table's been out, they are still finding new elements, which is really, really neat, you know, what we're making discoveries. Just like these, even now, as long as we've been on this planet, they still find animals that they don't even know about. And this is not in the textbook anyway, so if you don't have your textbook, then what is the best known conductor of electricity? Yeah, silver is the best known conductor, followed by who? Copper is number 2, followed by who? Gold is number 3, followed by 4. Aluminum. Aluminum is the 4th best conductor of electricity. And this is a electricity conductance thing that came off the internet. I don't remember where I got it. I should have gave credit to wherever it came from. But this shows the basic conductors that we use. And the bigger the number, the better the conductor. So down here we've got 63 times 10 to the 6. It looks like down here. But air's got it to the minus 14. So air definitely would not be a good conductor. It would probably be a good insulator. And we use air a lot to insulation. Thank goodness, you know. If we couldn't insulate with air, then we couldn't send power line. We couldn't send power lines through the air, right? So air is a real good insulator. Copper, anneal copper, just heated copper. This chart did split up anneal copper, but we're not going to deal with that. So you can look. Silver is 63 times 10 to the 8th, and then copper is 59.6. So copper is a really good conductor. And then we have gold, and then we have aluminum. And what's the 2 most widely used? Yeah, copper and aluminum. Why don't we use silver? We use silver as a plating. We'll get into that in a minute. So basically, an atom consists of 2 parts. It consists of a nucleus and then what orbits around the nucleus, right? We call them electrons. Okay. Then the nucleus consists of protons and neutrons. And what charge does the proton have? Positive, and electrons carry a negative charge. And the charge of the electron is exactly, even though the electron is smaller, is exactly offsets the charge of the proton. The proton is actually bigger. An electron can get a atom can give up an electron, but we don't screw around with the nucleus, right? What happens when we screw around with the nucleus? We might get what we call a chain reaction. Yeah. So the electron carries a negative charge, the proton carries a positive charge, and the neutrons are not charged. Are we okay? Electrons and protons have the same charge but opposite polarities. Since opposite polarities attract, the electrons orbit around the nucleus. And they orbit in what we call shells, right? Since the electrons and protons have equal but opposite charges, a balanced atom would have no electrical charge unless we get rid of an electron. So electrons can move about, certain electrons. Energies are grouped into energy bands we call shells, also called energy levels. Electrons near the nucleus have less energy. Electrons in the high shells have the most energy. The outermost shell is what we refer to as the valence shell. And the electrons loaded in this shell are called valence electrons. Now, back in chemistry, you learned that we move from shells. When we move from shells, every shell will have a certain number of electrons in it. But what's nice about the valence shell will have at least one, but it'll never have more than 8. Unless it's balanced, right? Unless we do something strange. If any atom has only one shell, the maximum number is 2. After the first band, the valence shell can hold a maximum of 8. What the valence shell does is it determines the electrical conduction capabilities of the atom. Are we okay? If the valence electron gets enough energy, it can escape from the shell. The escaped electron is called a free electron. The process of losing or gaining electrons is what we call ionization. So as soon as if one of the shell goes out of the valence shell, then the atom would become positive, because now the protons, we have more protons than we have neutrons. If an atom gains an extra electron out there in the valence shell for some reason, then the atom would become negative. And it would be a negative ion and a positive ion. Are we okay? That makes sense? So this is the way we bond. Atoms with 2, 3, and 1 electron in the valence shell are considered good conductors. Of course, the best being 1. So when we start looking at the arrangement of these atoms, and we see these devices that's got 1 electron in that outer shell, those are going to be good conductors. But it could have 2 and it could have 3. But the best ones, so gold, silver, and copper, when we look at those atoms and look at the shell, they're going to have 1 electron. Aluminum has 3. Atoms with 5, 6, and 7 electrons in the valence shell make good what? Insulators. Of course, 8 is the best. That sucker is fat, dumb, and happy. These are going to be your noble gases. They don't want to combine, you know. They're just there, you know. Atoms with 4 electrons in the shell are not good conductors or insulators. These are commonly referred to as what? Semiconductors. So now y'all know what a semiconductor is. So when we start looking at semiconductors and look at the periodic table, we'll see all of them line up, and they've all got 4 electrons out there in the shell. And there it is. So you can see, let's advance it. Oops, it didn't work. So I don't know, it's supposed to come up. So we can look down this guy right here. So here's copper. And by the way, what's neat about this chart, if y'all can see it or not, and I don't know if I can blow it up, this shows the actual shell. So that says 2, 4, 8, but that last one out there says 1. Can you see it at the very bottom? And what does it say right here? 1, this says 1, and this says 1. So there's copper, gold, there's copper, silver, and gold right there on top of each other. Then I get over here to aluminum. Can you see what it says in the valence shell? It says 3. So it's in the range of a conductor, right? It's right below a semiconductor, but it's still considered to be a good conductor. But when we start talking about the resistance of a conductor, aluminum would have more resistance than copper, gold, or silver. Are we okay? Now look at this guy right here. Look at 14. Carbon, what does it say? 4. Silicon says what? 4. Germanium says 4. Tin has 4. Lead has 4. And this is labeled wrong. I forgot what this is. But it has 4 also. Now these are all considered to be semiconductors. The two most commonly semiconductors are germanium and silicon. Silicon vastly outnumbers the amount of germanium we have. Germanium is getting less used. It's used in some special purpose applications. But silicon by far is the actual most widely used. both have exactly 4 electrons. Germanium valence electrons are in the 4th band. Silicon valence electrons in the 3rd band. So what happens is the ones out there can get rid of them. So silicon is more stable at high temperatures. Are we okay? Everybody okay? Any questions? So this is a atom, silicon atom, and a germanium atom. So what we do is we have atoms, or elements, right, which consist of atoms. And then we take those atoms and somehow atoms bond together to make molecules, right? That makes sense? Anybody know the 2 types of bonding we have? So if we can bond elements together, then we wouldn't have molecules, right? You understand? So we wouldn't have salt. So there's not a salt listing in the periodic. We wouldn't have water, which we call water, H2O. So that means somehow we've got 1 hydrogen atom that has bonded with what? 2 oxygen atoms. So they come together and somehow they bond and they form these molecules, which gives us compounds. What we do is and I think, let's see. This screen, this projector does a real good job. So can y'all see that pretty good? So we'll watch this video right here. This talks about bonding, how atoms bond, which are pretty neat.